So in problem number 2, and again, we'll go over this whole thing tomorrow, but I thought I'd get these out of the way since we've never really addressed it like this before. So this is problem 2 on the practice DA. Bottom line is this: if you can make, I'll clarify this for you in a second. I have a better way to say this, but the more proper way to say it is really this: if you can make an equation look like this, it's linear. If you can't, then it's not. And so you might already kind of, when you look at it, you're like, okay, A is pretty obviously linear, but the point is on A, so what I'm given is y minus 5x equals 7. If I were to add that 5x to the other side, then I would get y equals 5x plus 7, right? So I have made it fit the mold of just a typical slope-intercept equation. Hold on a second here. So because I was able to make it look like y equals mx plus b, I can state that this is in fact a linear function. So I would just put like a circle around this and say it's linear. And I know it says explain your answer. And I think what I'm going to do, since I'm the one that gets to grade these, is I feel like if you can show me that it fits the mold, I would count that as an explanation. And there, I'll explain another way, and you might, if you don't like this explanation, then I can explain it another way here in just a couple of minutes for you. But take a look at part oops, that was part A, by the way, my bad. So this was part A. Take a look at part B. So what's given to me is negative 4x, and this one is a little bit strange. But if I were to try to get y by itself, so let's say that I did that, and I just say we left the negative 3y here, and then we left the 11x squared here, and then we brought the 4x across, you know that we can't add the 4x to the 11x squared because they don't have the same parts and pieces. You might say, but they both have x's, but you can't put x's together when one of them is a squared and one of them is a linear, so it doesn't work that way. So when I divide everything by negative 3, this is what I did to show my work, to explain my answer, if you will. When I divided everything by negative 3, I got this for my final answer. So I got y equals negative 11 thirds of x squared minus 4 thirds of x. And I certainly don't mean to insult your intelligence with this question, but I would be remiss if I didn't ask, does this fit the mold? Therefore, it is not a linear function. Okay, this is actually what we would call a quadratic function, and we'll talk more about those in a couple of months when we get to that unit in Algebra 1. We talk a lot about quadratics in Algebra 2, but we also talk a decent amount about them in Algebra 1. So when it's got x squared, it makes a different shape. It's a curvy shape called a parabola. In fact, everybody right now turn back to page 1. And then look at part A. Do you see that graph? It looks like an arc, or an arch, excuse me. That's what an x squared graph will always look like. Clearly not a straight line. Anything that's got x squared like that as its highest x power is always going to be a parabola. And that's what it would look like. So anyways, long story short, part B is not a linear function. So for that, I would just write the word non-linear. And you could write not linear, two separate words, if you like that better. That floats your boat. Any issues so far? All right, let's take a look at part C. And in part C, we're given negative 2 plus 5xy equals 10. If I were, again, my mission, I don't know that I explicitly said this, but my mission is to get y by itself. Like, can I make it look like the one at the beginning? Can I make it say y equals mx plus b? So my first step, obviously, is to get rid of the negative 2. So I'm going to add 2 to both sides. And I'm going to get 12. Because why not, right? 10 plus 2, I can add those together. No sense in writing 10 plus 2. That would just be weird. Now, what do I do to get y by itself? You would. And that right there is your cue to say that this is not a linear function. But let me show you the work, okay? So when I divide by 5x, where did the x go? Like, where does it wind up? Do you see it? I know you're writing stuff down, so you don't want to answer just yet, but do you see where the x winds up in this answer? Did you say underneath the 12? Is that what you said? Correct. I'm sorry, I just couldn't hear you. Yes. And when the x winds up in the bottom of a fraction, it is not a linear function. This becomes something called a rational function. So there's two rules. And again, let me finish these four and then I'll come back and explain, because for some of you that might be a little confusing. I'll explain a different perspective on this. But the bottom line with this one is that it does not fit the mold because of the location of the x. X is being a divider now, not a multiplier. For that reason, this is nonlinear. Got it? Let me show you something real quick. I'll just keep the recording on. Do you guys ever go to Desmos? Have you ever been there before? We love Desmos, don't we? We love that. So if I were to graph the function 12 over 5x, take a look at my television right now. Do you see that? I mean, of course you see it. It's a rational function and it creates asymptotes, the graph going like this, which we'll talk about that more in algebra 2 or pre-calc, but the moment that x is not a multiplier, but rather a divider, interesting things happen. And I don't really feel like doing a spin-off side lesson on why this goes this way, but I'd be happy to show you sometime. It would be a worthwhile discussion. But what you need to know right now is that this is what the function actually winds up looking like. And you're like, that's not a straight line, dude, right? For it to be linear, it's got to be a straight line. Obviously, that's the root word of linear. So C is definitely non. Got that? And then finally, let's head down to part D. And again, my mission, if I understand it clearly in part D, is, okay, get y by itself. And so I'm given y equals 3y plus 2x. Anyone want to make a guess right now as to whether or not it's linear? Just right now? I mean, we have work to do. I'm just throwing it out, seeing if anyone wants to make an early guess. Do you think it's linear? It is. Let's take a look, okay? So yes, to answer your question, wouldn't we do that? Yeah, there's a lot of things we would do. So to get y by itself, honestly, I might just take the 3y and bring it over here by subtracting 3y like this. So I'm going to wind up with negative 2y equals 2x plus 17. I want you to notice a couple things about this problem. Number one, the x hasn't gone to the bottom of a fraction. That's good. And I don't see any x squareds or anything like that. That's also good. Hint, hint. And so the last thing I want to do here is divide by negative 2. And if I divide by negative 2, then I'm going to be left with my answer. And I can compare it to the original mold that I'm trying to fit it into. What will my slope be right in front of x? Negative 1. So I could just put like negative x. You could put negative 1x if that's your thing. And then you could put like minus 17 halves, or you could put minus 8.5. I'm just going to leave it like this because no one's asking me to graph this. And so I don't really care if it's a fraction and not a mixed number. Does this fit the mold of y equals mx plus b? It does. Oh. It does. It has a slope, a straight constant slope of negative 1 and a y-intercept of negative 8.5. It's a perfect straight line. So this one is definitely linear. Okay, I just wanted to, before we change pages here, I wanted to put this in plainer English. This will get you through this part of the test. The first thing that's ever going to make you say non-linear, so you can put this in your notes if you'd like, it's up to you. To be non-linear, the first rule you can't break is no exponents on your x. In fact, just no exponents at all. Let's just keep it that way. If you see any x squareds or y squareds or anything, it ain't going to be a straight line. Okay. So that's the number one rule that you can't break to be a straight line. And number two is x can't be downstairs. And you would find pretty clearly that those are the two exact rules that we broke in parts B and C. In part B, we had the x squared, so we knew it wasn't going to be straight. And then in part C, our x migrated to the bottom of a fraction, which also tells us it's not going to be. Okay. We'll practice that some more tomorrow, just to make sure that you all understand. It wouldn't be fair just to do these and expect that you get it, but tomorrow I'll throw some more functions at you and we'll practice, is it linear or is it non-linear? Okay. The other, you should have had no troubles with 3, but again, we'll go over it tomorrow. The other one that I know that I've never shown you how to do is number 5 on the back page, part B. So what's happening here is we have a function named f. And I kind of, full disclosure, I'll say this on video, I kind of forgot that we did this in Algebra 1, but thankfully it's not hard. You guys are used to just putting into functions like numbers, like what's f of 4? That's easy. What's g of 3? That's easy. But what I've never asked you to do before is to find f of an actual algebraic quantity, like in this case, f of 6x minus 1. Some of you might have actually, the more confident among us might have actually gotten this right, because we might look at this and say, wait a second, I know what to do with functions. So good on you if you said, what's the worst that can happen, right? I'll miss it. But what's going to happen is all of this red stuff is going to replace the letter x. And you're not going to wind up with an answer like you're used to. You're not going to get 10 or negative 52 or something like that. You're going to get an answer that has x's in it. It's pretty weird. But let's have faith in what functions mean to us. Functions mean put in whatever someone tells you to put in. So in this case, all the red is going in place of all the red. So when I rewrite this out, as I always do, I'm going to write it as 3 space minus 5. Remember, what used to be in this space right here? That used to say x, but remember, my plan is to replace x with what someone told me to replace it with. So where it used to say x, I'm going to put 6x minus 1. That's okay, right? Not scary. And then it's a very simple algebra problem from here. This is like some early beginning of the school year 4 months ago kind of stuff. Like I can distribute and combine like terms, right? It's easy. So I'm going to take the 3 and I'm going to distribute it through the parentheses because it's what we do. What's 3 times 6x? And what's 3 times negative 1? Negative 3. And my answer isn't quite done because I've got like terms. What's negative 3 minus 5? So my final answer is 18x minus 8. Can you put a box around that? And that is the answer. That is f of 6x minus 1. So while I've got you here for about 6 more minutes, are there any other parts? Listen, I'm not saying that nothing against you. You should have known how to do every other part. But what else would you like to talk about while you've got me here? Yes. Uh-huh. The circle one? The ellipse? Sure. So on Alana's asking about problem number 1, and she's talking specifically about part D, which is the ellipse. So any stretched circle like that, we sometimes casually call them ovals in math. It's called an ellipse. So remember, the domain of a relation is just how far from the left to the right does it go. So if you were scanning at that graph from left to right, when would be the first x-axis value where you would look and say, I see the graph? How far to the left does the graph begin? -5. Good. So for my capital D domain, I'm going to set an interval, except I should have done a square bracket. And the interval for the domain starts at -5. Now, as you scan starting at -5, and you're like scanning vertically and you're looking, you keep seeing the graph as you look up or down, right? It's not a function. We're clear about that, right? It's not a function. But as I look up or down, the graph exists above and below me. When does the graph stop existing? At -1. So when we talk just about horizontally, how like wide is the graph from where to where? It exists from -5 to -1. Now we have to change our thinking for the range, because remember, the range isn't about left to right. The range is from low to high. So now I switch and I start looking sideways and I come in from the south. And as I'm scanning, boom, where's the first time I say, I see you, Graphy? How low am I? Good job. So my range runs from -2, and then I keep seeing Graphy up until where? So that is your domain and your range. So you would write those two down. And then for this, I would just write not a function. And why is it not a function? Yeah, it fails that test. What's that test called that we give things? Yeah, it's called the vertical line test. And if you were to scan that graph with a vertical line, that line would see the graph above and below itself. Like the graph exists above and below itself. Therefore, it's not a function. Does that make sense to you? What else would you like? We got a couple minutes here. Any other points of clarification? Okay. Before you start packing up and shuffling papers and making noises that prohibit you from hearing me, let me say this. Make sure you have this thing completely done as soon as you get to class tomorrow. We'll go over the whole thing, and then I'll practice some of the more sore spots with you. And don't forget to start making your page of notes, okay? T-minus 47 hours and 15 minutes ish.